Hello students, you are welcome to final lecture on principle of electrical measurement. In the previous lecture, you have learned about effect of internal resistance on the terminal potential difference of a battery in a circuit, and also you have learned about the working principle of galvanometer and how to use a galvanometer to measure as an ammeter of voltmeter. However, in this lecture, you will learn about the working principle of potentiometer and Wheatstone bridge and use their working principles to solve problems. Precisely, at the end of this lecture, you should be able to explain the working principles of potentiometer and Wheatstone bridge, solve problems using working principle of a potentiometer or Wheatstone bridge. A potentiometer. Recall from part 1 lecture, you have known how to measure EMF of a source or potential difference across the circuit using a voltmeter. An ideal voltmeter should have an infinite resistance so that it draws no current when connected across a source of EMF. Practically, it is not possible to manufacture a voltmeter which will not draw any current, however small. In order to overcome this difficulty, there is need to use another measuring device which draws no current from it, and this device is called a potentiometer. In the potentiometer circuit shown in figure 8.10, AB is a wire of uniform cross-sectional area of length L, and G is 0 center galvanometer, and J is the jockey, and K is the key. So the potential difference along the wire of the potentiometer is proportional to the length if the current is constant. When the EMF E1 of a cell is balanced against the potential difference V1 along a length L1 of the wire, and another EMF E2 of another cell is balanced against potential difference V2 along the length L2, then E1 divided by E2 is equals to V1 divided by V2, which is equals to L1 divided by L2. Applications of potentiometer. Some of the applications of potentiometers are: 1. Potentiometer can be used for calibration of an ammeter. Potentiometer can be used to calibrate a voltmeter, and potentiometer can also be used to determine the internal resistance of a cell or used in comparison of resistance. It can also be used for comparison of EMF of two cells. Advantages and disadvantages of using potentiometer. One of the advantages of using potentiometer is that the scale of the potentiometer can be varied and made long. Another advantage is that adjustment and measurement is by non-metal. Also, a potentiometer draws no current from the circuit under test. Another advantage is that connecting wire may be thin since no current passes through them, and direct calibration with a standard set is possible with potentiometer. The advantages of potentiometer are: 1. They are relatively cumbersome and it is slow to use, and temperature of the wire must remain constant, and wire is assumed to be of uniform thickness, and faults may arise due to breaks in the circuit or incorrect connections. Example 2. From the circuit below, a potentiometer wire of length 1.0 meter has a resistance of 10 ohms. It is connected in series with a resistance and cell of EMF 2 volts and of negligible internal resistance. A source of EMF 10 millivolts is balanced against a length of 0.4 meter of the potentiometer wire. What is the value of the external resistance? Example 2b. A potentiometer circuit is used to compare the EMF of two cells, E1 and E2. The balance point is obtained at lengths 30 cm and 45 cm respectively for E1 and E2. What is the EMF of E1 if E2 is 3.0 volts? this is the circuit diagram for example 2a. Since you have known that a potentiometer can be used to compare resistance of two resistors. From this circuit diagram, the given parameters have been identified. So from the formula of a potentiometer, from this diagram, the ratio of the resistance RAB to the resistance at which the potentiometer is balanced is equal to the ratio of their length, that is RAB divided by RCB equals to LAB divided by LCB. Since RAB is equal to 10 ohms and RCB is unknown in this case, therefore we can make RCB the subject of the formula. RCB will now be equals to RAB multiplied by LCB divided by LAB. This implies that RCB equals to RAB is 10 ohms times LCB 0.4 meter divided by LAB 1.0 meter. This implies that RCB equals to 4 ohms. Since a potentiometer can also be used for comparison of two EMFs, so from this circuit diagram, the two EMFs E1 and E can be expressed as E1 divided by E equals to ratio of their resistances. In this case, E1 is total resistance is external resistance R and the resistance of the potentiometer, which is RAB. That is R plus RAB divided by, in this case, the EMF E is balanced at point CB. In this case, the resistance RCB since resistance RCB has been calculated to be equal to 4 ohms, by making R the subject of formula in this case, R will be equals to E1 RCB divided by E minus RAB. Therefore, R equals to E1 is 2 volts multiplied by resistance RCB is 4 ohms divided by E is 10 times 10 to the power minus 3 volts, which is 0.01 volts, minus RAB is 10 ohms. Therefore, our R will now be equals to 8 divided by 0.01 minus 10. This implies that R equals to 800 minus 10 ohms, which is equals to 790 ohms. That is option A is the correct answer. The circuit diagram of example 2b is shown on this slide. Since a potentiometer can be used to compare EMF of two sets, from this circuit diagram, the ratio of the first EMF, which is E1, and the second EMF, which is E2, is equal to the ratio of their length at the balance point, which is L1 divided by L2. Since E2 is equal to 3.0 volts and E1 is unknown, therefore let's make E1 the subject of formula. E1 is equals to L1 E2 divided by L2. This implies that E1 equals to, since L1 is equals to 30 centimeter, multiplied by E2 is 3.0 volts divided by L2 45 centimeter. E1 equals to 90 divided by 45 volts, which is equals to 2 volts. Now practice this exercise 3. Exercise 3A. The resistance wire AB shown in the circuit below is 100 cm long. When AC is equals to 60 cm, no deflection occurs in the galvanometer. Find the resistance R. Question 3B. In a potentiometer circuit, balance point is obtained at 45 cm from end A when an unknown EMF is measured. The balance point shifts to 30 cm from this end when a set of 1.02 volts is put in the circuit. Standard cell E always supplies a constant current. Calculate the value of the unknown EMF. Now we move to another measuring device, which is called a Wheatstone bridge. You have learned that a resistance can be measured by Ohm's law using a voltmeter and an ammeter in an electric circuit. But this measurement may not be accurate for low resistances. In order to overcome this difficulty, we can use a Wheatstone bridge. It is an arrangement of 4 resistances which can be used to measure one of them in terms of the other 3 resistances. Wheatstone bridge consists of a network of 4 resistors P, Q, R, and S, as well as the battery E and galvanometer G, as shown in figure 6.11. Of the 4 resistors, P, R, and S are known, whose values are adjustable while Q is unknown. From figure 8.11, when the bridge is balanced, that is, the galvanometer shows non-deflection, then at balance point, P divided by Q is equals to R divided by S, or Q is equals to P multiplied by S divided by R, where P, S, R, and Q are resistance. Example 3. Determine the value of resistance R in the figure shown below. Solution. To determine R, recall at balance point, resistance RAB divided by resistance at arm BC is equal to resistance at arm AD divided by resistance at arm DC. Therefore, RBC is equal to R, which is equal to product of RAB and RBC divided by RAD, which is equal to 5 multiplied by 4 divided by 2, which is equal to 10 ohms. Exercise 4. You are to calculate the value of resistance R shown in the circuit below when there is no current in the 80 ohms resistor. We have come to the end of lecture on principle of electrical measurements. I hope to meet you in the next lecture where we shall be discussing something on electromagnetic waves. Thank you for listening.